Here we have a relatively easy CR strengthen question. So what we're going to do first, as always with CR, is we're going to go to the question stem first. That is the section that tells us what kind of question type we're looking at. As always, I had to redact certain portions. If you'd like to see the full unredacted question first, go ahead and click the link in the description box. Come back when you're ready. Here we go. Which of the following would most strengthen the astronomer's argument? Very straightforward strengthen question. That's part of what makes it easy. There's no confusion as to what the question type is. It literally says what would most strengthen. And because we're strengthening the overall astronomer's argument, there isn't a specific portion of the argument that we need to focus on. So it's essentially the whole thing, with the conclusion being the most important. So if I was doing this question, the first thing I would write down is probably S. It's a strengthen question, and I might even rephrase it a little bit. You know, what would maybe strengthen the astronomer? Just to keep in mind who I'm here to focus on, although obviously the whole thing is about the astronomer. So very straightforward in the way in which this question is being asked. Let's get to the passage. I'm gonna cover up the answer choices so we're not tempted to cheat. Most stars are born in groups, each star in a group forming from the same parent cloud of gas. Okay, great. So here might be like the little parent cloud, right? And the stars are being born in groups. Here's a little group of stars being born. Here's like maybe another little group of stars being born. I know it's a bit silly to sort of draw pictures, but I do find that if you are a visual learner, that drawing pictures can be incredibly helpful to understanding the argument. Sometimes when you just read these really dry words, it's not as clear for you, but if you stop at every period or every semicolon and almost diagram it like a little game of Pictionary, sometimes just doing that can unlock it for you. Next sentence, each cloud has a unique chemical composition. Okay, so it's got a little chemical composition. I'm just gonna write H2O because that's the first chemical composition I can think of in my head. Oh, there we go. So we did that. Okay, next and final sentence. So therefore, big keyword that tells us here comes the conclusion. Whenever two stars have the same chemical composition, they must have originated from the same cloud. Okay, so if you've got two stars, let's say you've got these two and they're both O2, that means that they came from the same cloud. All right, so great. So if they must have come from the same cloud, right? And that kind of tells us that these parent clouds, that the parent clouds, it's not like you could have this parent cloud give birth to stars that have an O2 signature, but then you could have this parent cloud over here also doing the same thing, right? Because if that was true, let's say these all had O2 as well, well then this star right here and this star right here, they would have the same chemical composition, but they said that that's not possible. So if that's not possible, then it means that these different parent clouds can't emit the same signature. So what would strengthen this would be to prove that, essentially. So that would probably be my prediction. Something like, you know, like different parent can't have, maybe doesn't equal, I don't know, O2 or something. I'm just getting a lot of use out of oxygen today. Something like that would be kind of the idea that this is hinging on. Great. So we have a pretty good understanding of this. We have a fairly decent prediction. Again, does our correct answer have to literally be phrased like this? No, but it does need to be something that would support this conclusion that, you know, you can't have two stars that are both O2 unless they came from the same cloud. It's got to be the same cloud. All right, so let's look at some answer choices. A says, in some groups of stars, not every star originated from the same cloud. Okay, so this might be tempting because we're talking about not originating from the same cloud, right? But specifically what this is leaving out is the idea of the chemical composition, right? That's really what we're here to strengthen. So this leaves that idea out. What's interesting is if we even do a quick scan, B talks about chemical composition, so does C, so does D, and so does E. So it's sort of odd that A is the only one that doesn't talk about chemical composition when the entire crux of the conclusion was all about the chemical composition. So sometimes even just a keyword scan can give you a little bit of a clue as to what you're looking for. B says that clouds of gas of similar chemical compositions may be remote from each other. Okay, well, this idea of the proximity of the clouds, whether the clouds are close or far away, has nothing to do with the conclusion. It's not about the physical location or the proximity of the clouds. It's about whether the stars could have the same chemical composition if they came from different clouds. Like, can they both be O2 if they came from two different parent clouds? That's really that's our scope here. So B is also out. C says, whenever a star forms, it inherits the chemical composition of its parent cloud. Okay, that would strengthen it, right? Because we're saying then, oh, no matter what, the stars always share whatever it got from its parent cloud. Okay, that sort of strengthens the scenario here. Is it the one that strengthens it the most? We don't know, but we'll certainly hang on to it for now. Their D&E could strengthen even more. Sometimes it is just a question of that superlative most. You might have a weaken question that asks which of the following most weakens, and you might have two answer choices that weaken, but just one weakens a little more. So I always encourage you to kind of go all the way through the answer choices. We wouldn't just stop here and go, oh, it's C and we're done. You know, obviously we want to take the time to get through D&E, see if it does a better job or not. D, many stars in different parts of the universe are similar in their chemical compositions. Okay, so again, different parts of the universe. It's a little bit like B, where it said remote from each other, where it's focusing on the physical location and the proximity of these celestial bodies to each other. And that's not the focus of the conclusion. It's about the stars and their chemical composition and where they originated from. So D is a little bit like B, wrong focus. E, astronomers can sometimes determine whether a star has the same chemical composition as its parent cloud. Okay, well, whether or not astronomers can determine this sometimes or all the time, that doesn't strengthen the idea of whether two stars have the same chemical composition, that whether or not they originated from the same cloud. It's more just about like, oh yeah, you know, here's how far we've progressed in terms of what astronomers can and can't do. It's like, okay, but you know, again, it doesn't have the right focus. The claim in the conclusion has nothing to do with the abilities of astronomers. Therefore, E is also out. And our correct answer is C. Relatively straightforward, strengthened question, maybe a little intimidating because it's talking about, physics and astronomy. If you have any questions about this problem or any others, feel free to ask me in the comments below.